Hey, welcome back to Leveling Up with me. In the last video, we identified and defined the different parts of an algebraic expression. In this video, we will be learning how to evaluate and how to simplify algebraic expressions. Before we get into today's topic, let me quickly recap what we covered in the previous video by briefly going over the major parts of an algebraic expression. Let's say we have the following expression: 2x minus 7. Now, let's identify each part of the algebraic expression. This 7 is considered a constant term. Or just a constant. A constant term, also known as a numerical term, is a value that remains fixed and does not change. The subtraction sign that you see here is called an operation symbol. And this operation symbol separates the constant term from the algebraic term. Algebraic term. Subtraction sign is the operation symbol. Let's move on to the coefficient. The 2 will be considered the coefficient because it is the number in front of the variable. In other words, this number multiplies a variable. And lastly, x would be our variable. A variable is used to represent an unknown value or quantity. And there you go. So, if you want a more in-depth overview of what an algebraic expression is and its parts, I highly encourage you to watch the last video. Now, let's get into today's topic. First, we will cover how to evaluate algebraic expressions. This should be fairly straightforward. Let's say we have 2a minus 3 given that a is equal to, let's say, 5. We have to replace all variables with their assigned values. In our example, we have only one variable a, which is equal to 5. We are going to substitute a is equal to 5 into the expression 2a minus 3. So we would have 2 times 5 minus 3. Notice that all we did here was replace the a with 5. So 2 times 5 is 10 minus 3. This will give us 10 minus 3, which gives us 7. So our final answer would be 7. Let's continue with some more examples. So I've created this table here. It contains 3 algebraic expressions, each of them containing only one variable. The variable that we're dealing with is x. Now, we want to fill in this table. I would highly recommend that you pause the video and try filling out the table yourself. Alright, I suppose you made an effort to fill out the table. Let's go over it together. So, in this second row here, we have x equal to 0. All we have to do is replace this x with 0. So it'd be 0 plus 9 gives us 9. We move on to the next column. We have 7 times 0 equals 0. And then we move on to the last column with the algebraic expression of 5x minus 2. We'll replace x with 0. We know that 5 times 0 is 0, so we're left with 0 minus 2, which gives us negative 2. Okay, let's move on to the next row. Now this variable has changed, right? The variable is now equal to 2. X is equal to 2. We're going to replace x with 2. So it's going to be 2 plus 9 equals 11. 7 times 2 is equal to 14. 5 times 2 minus 2. We know that 5 times 2 is 10. We subtract 2. That gives us 8. Okay, let's move on to the next row. We have x is equal to negative 1 now. We replace x with negative 1. Negative 1 plus 9 gives us 8. 7 times negative 1 gives us negative 7. And lastly, 5 times negative 1 minus 2. 5 times negative 1 is negative 5. Negative 5 minus 2 will give us negative 7. Alright. Last row. X is now equal to 7. 7 plus 9 will give us 16. 7 times 7 will give us 49. And 5 times 7 minus 2 will give us, 5 times 7 is 35. Minus 2 will give us 33. Now let's go over how to simplify an algebraic expression. Pull it up. Okay, simplifying algebraic expressions. To simplify an expression, you would add or subtract the coefficient of the like terms. Like terms are terms that have the same variables with the same corresponding exponents. Like terms can also be constants. However, algebraic terms cannot be added or subtracted from constants. So let's work on the first example. We have 4t plus 1 plus 6. The first thing we want to check is if there's any like terms. Now you see we have two constants here. We have 1 and 6. We can combine these terms. So 1 plus 6 would give us 7. So this would simplify to 4t plus 7. Now we check again to see if there's any like terms. As you can see, there aren't any more like terms, so we would leave it as is, and this would be our final answer. This would be its most simplified form. Let's work on another example. We have 4y plus 5y plus 3. Okay, do we have any like terms? Yes, we do. 4y and 5y are like terms. Why? Because they have the same variable and they have the same corresponding exponent. They have the same exponent of 1. So all you have to do here is add the coefficients. So 4y plus 5y would give us 9y, and then we're left with 3. So 9y plus 3. Now we check again if there's any other like terms, and there isn't, right? So we leave it as is, and this would be our final answer. In the next video, we will cover how to expand and factor algebraic expressions. That's it for this video. Thanks for watching. Feel free to like the video and subscribe so you don't miss future lessons. I'll see you in the next one.